Okay, you're ready for section 1.5, which is all about change in quantity and subtracting real numbers. So we're actually going to start here with subtracting real numbers and then talk about an application of that, which is change in quantity. With subtracting real numbers, the awesome part is that it's going to be very related to section 1.4 where we talked about adding real numbers. So we just want to understand the connection between those two operations. What does it look like when we need to now subtract and do some subtraction when negative numbers are involved? Understand how to do that, understand how to use those negative numbers in our calculator as well, and then focus in on change in quantity. So let's start off with that subtracting of real numbers. So a property that can be useful, not with every problem, but that can be useful, is that when we're doing subtracting, it turns out that A minus B, that's the same thing as taking A plus a negative B. Okay, so thinking about that negative sign instead of as the operation as it attached to that second number there. So anytime, remember that we were adding numbers of different signs, we were actually subtracting. So that subtraction problem is always A minus B. So again, it's not always useful to think about the subtraction that way. Sometimes it's just more useful to think about it as a subtraction problem, but sometimes that can be helpful. Another thing we want to remember with subtracting numbers is that anytime we have the opposite of a negative number, that number becomes positive. So anytime we're subtracting a negative number, that actually becomes addition. Okay, so we're going to use those two properties to our advantage here to work through, we're going to work through several examples here of subtracting real numbers. So as we're thinking about examples here, the most simple example we can look at is subtracting two numbers that are both positive, where the larger one comes first and the smaller one comes second. So that one should be something we can do in our heads. 9 minus 5 is just 4. But what happens is things start to get a little more complicated, like when we have something like 3 minus 7. When we have 3 minus 7, we start to think, oh, I can't take 7 away from 3 because 3 is not big enough. And that's where we start to end up with answers that are negative numbers. And this is an example of one where maybe, at first at least, it might be helpful to think of this as the equivalent addition problem. So we can think about this instead as 3 plus a negative 7, and then apply those steps back from section 1.4 for adding real numbers together. So what we do here is we think, okay, we still need to do a subtraction problem because we're adding two numbers of opposite signs. So remember what we did here? We thought about just the numbers without their signs. So my two numbers are 3 and 7. And then you always just do the subtraction problem that's basically easier. Take the larger one minus the smaller one. And I wrote down the wrong number there. 7 minus 3. And 7 minus 3 is 4. But remember, we always take the final answer to be the number with the sign of the bigger number. So the answer here is 4, but 7 was originally a negative number, right? We can see that both here and in the addition version of that problem. So that means my final answer needs to be negative, which makes sense. I had 3 and I had to take more than 3 away. So I went into the negative numbers. I didn't have enough to take away. Whereas here I had a positive number, I had enough to take away, and so I ended up still with a positive number. Okay, so this might help. This is just a way to think about it. If you saw that that was negative 4 from the beginning, that's awesome. Okay, and the more you do them, you might start to see some of those things a little bit more clearly. But that's what's going on there. If we take away more than we have, then we're going to end up with negative numbers. Okay, now all these same properties apply with fractions, decimals, things like that. So we're going to look at another couple of examples here. So what if I take 2/12 minus 7/12? What happens here? Now I have a common denominator situation, so I can put those over the same denominator. That's 2 minus 7 over 12. And then remember, you're still doing a subtraction problem here, but instead of thinking, okay, 2 minus 7, where do I end up with there? I can think, okay, I'm dealing with the numbers 7 and 2, so let's do the easier subtraction problem to know that my answer is going to be some version of 5, positive or negative, but I have a smaller number and I'm taking away more than I have. So that should end up being a negative number in the end. So my final answer should be negative 5 over 12. And that's a simplified answer. 5 and 12 don't have any common factors. And there we go, we've got it. That's our final answer. Okay, so works with fractions just the same. Let's try a decimal problem as well. Again, I'm going to stick with the ones where we've got a smaller number minus a bigger number, because we know how to do bigger numbers minus smaller numbers. Okay, so if you're starting to see the trend, if I have a smaller number minus a bigger number, I'm always going to end up with a negative here. So I think, all right, I still need to do a subtraction problem. So when I think about what this should be, over here I'm thinking the opposite, just to get the number, and then I know it's going to be negative in the end. So I think, okay, let's take 8.5 instead, the bigger number minus the smaller number. Remember with decimals, when you're subtracting, the decimal always goes in the same place. So here we just take 5 minus 1, which is 4, and 8 minus 6, which is 2. So my final answer should be 2.4, but again, I had took more away than I had, so this answer should be a negative 2.4. Okay. Let's make this just a little more complicated, all right? So we know what to do when it's a bigger number minus a smaller number. Hopefully we're starting to see what to do when it's a smaller number minus a bigger number. But what happens when I start to get more negatives involved? So what happens when I have 5 minus negative 6? What happens when I have minus a negative number? When I start to get more negatives, things start to get more confusing. But remember our property, right? This is where we want to remember this property here. Two negatives come together to be a positive number. So minus a negative number will actually be a positive. So we have 5, those two negatives come together to be a positive. Subtracting a negative is the same thing as adding whatever that number is, which in this case is 6. So those two come together. Some people like to kind of combine them right here to see that big plus sign there. Something like that is a good way to remember those things. Okay, so actually here we're just doing 5 plus 6. Straightforward problem, two positive numbers added together to be a positive 11. Okay. About as complicated as it can get is with this next one, where everything's negative. So I have a negative number minus another negative number. So again, first things first here, simplify your negatives. I have two negatives here, those are come together to be a positive. So that means now I've got negative 2 plus 8, right? Both of these come together to be this positive here, okay? So negative 2 plus 8, and now we're in one of those scenarios where we're adding two numbers of different signs. If they're different signs, we always think about the subtraction problem. We have 2 and we have 8, so we need to take 8 minus 2, which is 6. So my final answer here is either positive or negative 6. I check the sign by comparing the 8 with its original sign, which was positive, which means my final answer is positive. All right, so we just have to kind of remember back to the rules from 1.4 as well, and the fact that two negatives will always come together to be a positive. All right, so that's kind of all your different scenarios there. I'm going to do just one more like that. Since that one's kind of the more complicated one, let's do one more like that with some decimals. So what if we had negative 5.2 minus a negative 1.3? Okay, so maybe pause, give this one a shot, see if you get the right answer. Also good too, as you're going through this, to type these things in your calculator, Make sure you don't miss any of those negative signs when typing it into your calculator. That's a common error. And make sure you're getting those same answers as you are by hand. So here, did you bring the two negatives together first here to become a positive? So you're actually looking at negative 5.2 plus 1.3. So we're thinking about both positive versions. We know we're going to subtract because we're adding two numbers of opposite signs. So we need to subtract the larger minus the smaller. Anytime I'm doing subtraction by hand, I like to write it vertically. I'm going to need to borrow from the 5, and I will end up here with 3.9. Now always check your final sign. So here my answer is going to be positive or negative 3.9. Look here to think about whether it should be positive or negative. 5.2 was our bigger number. It started off negative, which means my final answer should be negative. All right, so let's apply this. Let's see where we would end up subtracting numbers, having several subtractions going on in a problem, things like that. One of the biggest applications of this is change in quantity. And this on its own has a property to remember. So change in quantity, one big thing to remember here is that change is always the end amount minus the beginning, which we typically end up switching around. We want to switch it around because we'll read the beginning amount first and then the end, but always take the end amount minus the beginning when you're finding change. That will make sure that your change comes out with the right sign, so that when we have an increasing quantity, if that quantity went up, so it was higher in the end than it was in the beginning, that will have a positive sign. And if we do that subtraction correctly, we'll also see that a decreasing quantity, so if it went down from the beginning to the end, and I'm realizing here that I spelled quantity wrong up there. There we go. A decreasing quantity is negative. Okay, if you do your change the correct way with end minus beginning, these two things will be true. If you accidentally switched around, you'll have gotten the wrong sign and you'll need to make sure you make that correction. So let's give this a shot. Let's do an example to see if we can find change with the correct sign. So here's your problem. You can write it down with me. The percent of eligible voters who cast a vote, oops, there we go, who cast a vote in 1980 was 59.2%. In 2000, that number changed to 54.4%. And in 2012, that number changed to 57.5%. We've got some change in the percent of eligible voters who actually voted over the years. And we want to find that value of change. So we can see that the number's changing, but by how much did it change? So the first thing I want you to find is what was the change in percent from 1980 to 2000. So two very important things here. Make sure you get the right percentages from the problem and make sure you find the change by taking end minus beginning. So the end year here is 2000. In 2000, it was 54.4%. Remember, it's always end minus beginning, so we ended at 54.4%. In 1980, we started at 59.2%. So we're going to subtract that beginning amount, 59.2%. So notice our sign is going to be correct because from 1980 to 2000, it went from 59.2% to 54.4%. So the percentage went down. And we are going to get a negative number here because we're taking a smaller number minus a bigger number. So our final answer here will be negative, and let's figure out what that value is going to be. So it's going to be negative something, and remember here, always do the easier subtraction problem and just realize it's going to be a negative answer. So we're going to take 59.2 minus 54.4. We're going to have to do some borrowing if you're doing this by hand. And you should get 4.8%. Make sure we're in context, put that unit on the final answer. So what was the change? Not 4.8%, but negative 4.8%, to show that it decreased by 4.8% from 1980 to 2000. Okay, can you do that same thing and find the change instead from 2000 to 2012? Pause and see if you get the right answer. You should have taken 2012, which was 57.5%, minus 2000, which was 54.4%. Notice it went up from 54.4% to 57.5%. So we're going to get that positive answer because we're taking a larger number minus a smaller number. So my final answer will be positive. And again, I like to put it vertically if I'm doing it by hand. 5 minus 4 is 1. Bring that decimal down. 7 minus 4 is 3. So my final answer should be positive 3.1% to show that it did in fact go up by 3.1% from 2000 to 2012. Very important you do the end minus the beginning to get the correct sign to show that it's an increasing or decreasing change in quantity. Okay? Last application for section 1.5 is going to be change in elevation. And we break this one out because elevation is a little bit different because we want to talk about what kind of numbers we get when we're talking about elevation. So here are your two things to remember. Elevation can be reported as a positive or negative number. So a positive elevation is above sea level. So it is possible to have an elevation of 0, that would be at sea level. And you can report a negative elevation. A negative elevation just means you're somewhere below sea level. So that means when we're talking about elevation, we are talking in quantities that are going to be both positive and negative. And sometimes then finding the change can be a little bit harder because that might mean we're subtracting some negative numbers, right? We're throwing negative numbers into the mix. So let's look at an example of finding the change in elevation, and then you'll have some more to work on in your homework. Okay, so here's our example. Also just has some fun facts here that you may not have known. So the lowest elevation in the US is at Death Valley, which happens to be in California, at -282 feet. The highest is Mount McKinley, which is at an elevation of 20,320 feet. I want you to then find what is the change in elevation. And this next part is very important. What is the change in elevation from Death Valley to Mount McKinley. So you can always kind of think about these things first to make sure you end up with the right setup. So if you go from Death Valley to Mount McKinley, are you going up in elevation or down? Should your change be positive or should it be negative? From Death Valley, which is below sea level, up to Mount McKinley, which is above sea level, right? Below sea level because Death Valley is a negative elevation and Mount McKinley is a positive elevation. We should be going up. So let's make sure that we get a positive number here in the end. Now we're going from Death Valley to Mount McKinley. So we're ending at Mount McKinley and we're beginning at Death Valley. So that means we need to take our end elevation, which will be 20,320, and subtract our beginning elevation. Now, the subtraction is coming from finding the change. The beginning elevation is negative 282. So it's also key here that you don't end up missing one of those negative signs. If you do, you won't get the right answer. Because really what we need to do here and what we're seeing is that these two negatives will come together to be a positive. We need to find that change in elevation, we need to go up 20,320 feet, but add in that 282 feet that we first needed to go up to get to sea level. If you add those two numbers together, you will get 20,602 feet. Always put the units on there when you're in context. So my change in elevation is that I went up 20,602 feet. I'm seeing that up from it being a positive number. So very key here, those two negatives, both of them need to be there. The first one is from the fact that I'm finding change, and that always means I need to subtract. The second one is from the fact that the number I began at was a negative number. Okay, give that homework a shot and email me with questions.